Okay, so let's get this show on the road. We have today notes on 3-4, and our 3-4 notes are brought to you by the makers of Just Get It Done. Okay? Just Get It Done. They are a subsidiary of Nike Corporation, you know, the source of let's just do it. Okay? All right, just do it. Just Get It Done is what we're going to do today. You got about 12 minutes of notes, maybe. After that time, I expect you to complete today's assignment, ask questions as you're going, and I will go over one or maybe two of the questions that you may have after I let you struggle with it for a little bit, okay? Because I want you to know about what that is. If you don't struggle a little bit, you're just going to write something down and you won't care. You won't learn anything, okay? But if you try it on your own, and then you go, oh, that's it? I go, yep. Oh, okay. All right, I can make that change. So just keep that in mind. That's what we're going to be doing today. Now, know also that grades have been updated. Grades have been updated. Report cards will have the same information. Okay? So sometime during class, after notes, of course, check your grade on campus. If you have any discrepancies or changes or wonders, or maybe perhaps some assignments you should be getting in, make sure that you make a plan for this weekend to get them in Monday. Monday, ASAP is going to be delivered in third period. Okay, so keep that in mind. Anything else? Oh, yesterday's stuff, 3133 review, both pink sheets we did yesterday, and the 3133 quiz, and it was a quiz I did last year. Those are both due on Wednesday the 18th. Okay, get them done. Check online. I'm going to be posting those solutions online today, and I'm going to be putting them in the Wednesday file, the Wednesday, answers. So because it's going to be due that day, that's where I'm going to put it. I want to make sure you recognize doing those and understanding them is going to make your quiz easier. Okay? It doesn't make the quiz easy. It makes it easier. Your understanding of those will really help the quiz. Okay? Now, and it won't just be those for the quiz, because on the quiz we'll also do exterior angle theorem, remote interior angles from section 5, and this stuff on 4 will also be addressed in that quiz. So, with those said, today's objective, to relate parallel and perpendicular lines. Now, what we're looking at is transitive property of parallel lines. Theorem 3.8, notice it doesn't have a name. It can't be that important. We'll talk about it, and I will address why it can't be that important. Okay? Perpendicular transversal, hey, it's got a name. I should know it. Okay, so with today's stuff, we got transitive property of parallel lines. You will not see transitive property of parallel lines in any other textbook, probably, unless they taught here at Elk River High School with our attitudes about transitive property. Remember, transitive property is something's equal to something else, and then that same something else is equal to yet something further else. I skip the something else and they get together, right? Check out what's going on here. If I have line A parallel to line B, and I have line B parallel to line C, that's what those double marks mean, and that's what that single mark means when I'm talking about those lines. I can now say that B, A, and C are parallel as I'm going through, because if two lines are parallel to the same line, then those two lines are parallel to each other, right? Well, I'm going to use transitive property of parallel lines. Okay, that's what we're going to call it instead of theorem 3.7. Okay, gotta wonder, Bloom wants to put a name to it. I wonder if he uses it a lot. Might be on a test coming to us. Okay, the next one, theorem 3.8. I said, hey, it doesn't have a name, can't be that important. I want you to look at this for a second. If these are both perpendicular, okay, they're right angles. All right angles, we know something called all right angles are congruent. It's an actual little postulate. All right angles are congruent, okay, because they're 90 degrees and they work, right? Well, if those values are the same, what type of angles are they that I circled there on the board? Alternate interior, alternate exterior, corresponding same side. Which ones? Corresponding angles, okay. Are we okay with that? They are corresponding angles. Well, here's the deal. Because of the converse of corresponding angles, I know that these two lines have to be parallel because of the converse of corresponding angles. Okay? Because I could use that. But then some dude someplace else thought, dude, if I have a set of parallel lines and there's a transversal that's perpendicular to one of them, okay, it's got to be perpendicular to both of them, or excuse me, not that I'm ahead. In a plane, if two lines are perpendicular to the same line, then they are parallel. Well, by the converse of corresponding angles, it should work. Or we can just go, oh, I know this is perpendicular. They're totally going to be parallel. But also we use this one in construction, right? Okay, when I put it on my floor, I make my wall, I put up my walls, and when I put in my other wall to support the two outside ones, it should be that those two walls are parallel to each other, and the outside one, the one that's holding them together, if it's a rectangular type room, should be a right angle meeting there. Okay, so two separate walls that are perpendicular, another wall should be parallel to each other. Okay, now going on, my last one, perpendicular transversal, and I paraphrased that one and I muddled them together in that last statement. In a plane, if a line is perpendicular to one of the two parallel lines, then it is also perpendicular to the other. Okay, well, this one, if these are parallel, again, just by corresponding angles, I should be able to say that. But this is just a perpendicular transversal. If the transversal is perpendicular to one of the parallel lines, it's perpendicular to both. So, by the way, a perpendicular sign is it looks like a capital T. Okay, upside down. It is perpendicular. All right, that's the notation for perpendicular. Now, we're not doing this assignment. We got a different assignment. Don't worry about that. Okay. I'm going to do two proofs. One proving 3.7, transitive property of parallel lines. Okay. Now, and the other one's just a regular proof proving proving something else. I forgot what it is right now. We'll get there when we get there. What I want you to know during a proof, if I'm actually proving a certain theorem, that theorem, as sweet as it would be to use, cannot be used because that circularity of argument. Because I'm using what I'm proving in the proof, that doesn't work. It's kind of like me going on the witness stand to authenticate actual work that I did. It's like, hey, I do the best work there is. I could be the self-authenticator. They'd have to go out to a separate source to authenticate my work. They can't ask me to authenticate my own stuff. Okay, so when we are writing a proof, or proving, I should say, a theorem, we cannot use that theorem to prove itself. But we can use other things that will support it. Okay, so that's what we're going to do. So here's the deal. When you start with a proof, you have a given. Okay, so I have a given, and let's look at the diagram based on our given. So I have line L. Line L is right here, and I have that parallel line K. We have notation that states line L and line K are parallel over in the diagram. If it's not there and they have it in the given, go ahead and mark the diagram accordingly. So when you look at the diagram, you know about that information that's there. Now, the second part of that is that M is parallel to K. Okay, so if M is parallel to K, M and K are both parallel. All right. So what I'm about to do is I'm going to step you through how we know transitive property of parallel lines works. So when I'm thinking about this, I'm looking at the angles that I put in for these lines. Now, all the angles are on the same side of the transversal. Okay. Now, there's only two angle pair relationships that have the angles on the same side. Same side interiors and corresponding. Okay, corresponding angles and same side interiors have the angles on the same side of the transversal. But remember, same side interiors have them both on the interior of the two lines that are parallel to each other. Well, I don't have that here, so I won't be using same side interiors. So I'm really left with corresponding angles. All right. Now, the reason I said that is because of line L and K being parallel, I have 1 and 2 being congruent to each other because of corresponding angles. But I also have, because of K and M being parallel, I have 1 and 3 being congruent because of corresponding angles. So since I have both sets congruent because of corresponding angles, I'm just going to use the same line. So I got my given, because that's what I started with, and I got my corresponding angles postulate, and that's what I'm using. Okay? Are there any questions about that? Now, keep in mind, I set this up on this so you can see it. I'm hoping you're seeing it. I'm going to use transitive property coming up next, right? Check it out. 1's the middleman, so I get the dump 1. Okay, we'll be nice. We'll slow down, stop the car, and just let 1 get out nice and easy. Won't roll him out of the car. Okay? The drive-by drop-off. Angle 2 and angle 3 are congruent to each other because of transitive property. Okay, because that's pretty much our transitive property setup. So that's where I'm going. Angle 2 and angle 3 are congruent to each other because of transitive property. Now, excuse me. I've got 2 and 3 congruent. Now I'm just going to kind of hit those with a different color maybe. I'm going to go for red. So now 2 and 3 are congruent. I just proved 2 and 3 congruent. So what do I know? 2 and 3 are holding 2 lines still. They're not letting them move. Okay? They froze 2 lines along my transversal. The 2 lines 2 and 3 froze are L and M. Okay? Well, we just proved that 2 and 3 are congruent, and now we can prove L and M are parallel because we have corresponding angles are congruent. Therefore, by the converse of corresponding angles postulate, I can say those lines are parallel. And that was that stuff that we worked yesterday, okay? Or the day before, excuse me, Tuesday, or Monday, or Wednesday, yeah, that other yesterday. The line from the song yesterday, all my troubles seem so far away, really makes sense in that statement, doesn't it? Maybe my troubles are here today. Are you okay with this proof? Now, you're going to see more of them. We are about to embark on the next 4 weeks of doing more proofs than we have before, okay? Now, I don't do as many in chapter 3, but you will do a day on Tuesday, the 24th, when we get back from break. We'll be doing a day of proofs, just because everybody has an opportunity to have a little fun. Okay, fun with proofs, that's what we'll call it. Okay, so let's do one more proof. When you do proofs, read your given, read what you're asked to prove, look at your diagram. Okay, now I always got people go, oh, really? So I'm going to boil it down to putt-putt golf. Okay, when you play putt-putt golf, do you just put your ball down on the thing and just whack it away? Or do you look at where you're going so you don't have to like hit it so hard? Do you look at where you're going so you could probably carry them off a side wall so you can get closer to the cup? Okay, think about it. You look at your start spot, you look at the course, you look at your end spot. That's what we're doing in this proof. Every time we write one, we look at our start spot, the given. Okay, we look at our diagram, the shape of our hole. Okay, what do we got to do? The proof. Okay, where we got to go. And with those pieces of information, we then start constructing what we want to say. You do the same thing in papers. You have an intro, a body, a conclusion. You look at your material, you look at what you want to conclude, and then you start out with your intro about how you're going to do it and your body about how it's going to get done. Okay? Same idea with these proofs. So we have done a lot of them, but you got to start with your given. In a plane, A is perpendicular to B, B is perpendicular to C, and C is parallel to D. So And that sounds like gobbledygook until you start tapping out the diagram. So let's look at it. A is perpendicular to B. So A is perpendicular to B. All right, cool. Okay, and B is perpendicular to C. All right, A and C happen to be perpendicular to the same line. Okay, so I'm thinking already perpendicular. You know, if you're perpendicular to the same line, then you're parallel. We just went through that one. It's, you know, that's that perpendicular transversal thing. Well, let's check that out. Well, we're going to look at it. It's either that or 3.8. One of those two. I just vaguely remember. Look up above. Which one am I talking about? 3.8 or perpendicular transversal? 3.8. Okay, so right now I'm using 3.8. Okay, it's in my head. So I'm going to prove that A and C are parallel. All right, that way. But now I look at that C and D are parallel. And they want me to prove that A and D are parallel. And now I start smiling. Okay? Because right now I know that A and C are parallel. We can do that by theorem 3.8. And I'm looking at it and I'm going, well, you know, if A is parallel to C and C is parallel to D, do you see that other one? What was the first one we did today? Transitive property of parallel lines. I can use that and I'm done with my proof. Does it make sense, my steps? Without knowledge of the material I get to use to write for my reasons, I'm lost. The more I know, the more understanding of what I'm supposed to know I have, the easier these become. Now, they will not ever be easy, okay? I promise that. They will be easier, however, with practice and us going over the material that'll work for us, okay? Theorems, postulates, vocabulary. So, first thing, my given, okay? I just walked through everything. Now I'm ready to hit my ball, okay? So I'm addressing it, I got my given down. The next thing is I'm going to strike it and it's going to, hey, I know because of that given, A is parallel to C because of theorem 3.8. Okay? Now, the last thing, I know what I've got to prove is A is parallel to D, and because of transitive property of parallel lines, I'm able to get that done. And we did all that by looking at our given, looking at our diagram, and looking at the direction we are going to make our proof. And it's just like putt-putt golf. Okay? As far as, look at where I get the tee off. Look at the shape of the hole. Look at all the junk that they got in the way. And look at where the final cup is. Okay? So just make that connection on that as we go through these. Now, I'm done with what we're presenting for notes today. What? I love notes for it. I want to do more. No, remember, it's brought to you by the makers of Just Get It Done. Okay? We want to make sure that you get this done before you leave today for several reasons. One, the biggest one, I want to make sure that you have answers to questions immediately. The other thing is I had people yesterday miss out on class. I have news for you. If you guys could probably get that 3133, that very first one with the angle pair relationships done, no problem. And then you can do the quiz thing later, okay? And we'll be able to check your answers online. Remember, those online answers will be posted in the Wednesday 10/18 date. So you can check those out prior to your test, or I should say quiz, prior to break. Now, if you're going to be gone at break and you're taking off like on Wednesday, you can take that quiz early. I'll be ready for you, okay? You can take that quiz early as Monday if you're going to be out of here on Tuesday. But if you're going to be leaving tonight, have a great time, okay? So just keep that in mind.